2 is a is good to go. Now, the third question comprises of an exponent function, comprised of a trigonometric function, and then your normal um, um, normal variable, the algebraic expression, so algebraic function. No, let me just say normal algebraic function. So with this now, if you apply your law of indices, I'm sorry, if you apply the basic rules of addition and subtraction, this it means you can differentiate each of them separately. That's the rule of addition and subtraction. You can differentiate each of the terms in that expression separately. So we can differentiate e raised power of x separately. We can differentiate 3 sine x separately, provided I take cognizance of the operation that is involved, and then minus d dx of 5 over x raised to the power of 4. The x raised to the power of 5 raised to the power of 4. I hope you are seeing that. So with this now, remember that I said if you want to differentiate an exponent function, what do you do first? You differentiate what you have as the power here, which is s. If you differentiate s, what do you have? You have 1. Because s is the same thing as s raised to the power of 1 will give you, remember I always tell you that if you have just a variable and there is no coefficient beside it, it means the coefficient that is there is an invincible one, because 1 times anything will give you that original number. That was why they didn't bother to write 1 there. So in this case now, you are saying this will become 1 times 1, x raised to the power of what? 1 minus 1. And this will give you 1 times s raised to the power of 0. Any raised to the power of 0 is what? Is 1. So when you differentiate a variable with power 1, you get 1 as your derivative. When you differentiate a variable with power 1, your derivative is going to be 1. So if you differentiate s here, I'm going to have 1 times, then you write the original function you are trying to differentiate, e raised to the power of x. And that's all. Then for this one too, remember our constant and multiple rule, that if you want to differentiate a function that has if you want to differentiate a function that involves a constant value and uh, and a function, what do? You can factorize the, you can take the coefficient out, you factorize the coefficient out, and then you take the derivative of the function that is involved, that function of s that you have. So in this case, now I can write this as the d ds of 3 sine s, d ds of 3 sine x is the same thing as writing 3 dds of sine x. I hope I'm making sense. And you know that from the standard rule that was shared in this video, in the previous video, you will see that the derivative of sine s is what? Is cos s. So this one become 3 times derivative of sine x cos x, and that will give you what? 3 cos x. So this will give you 3 cos x minus, now you want to differentiate the ds of 5 times 1 over x raised to the power of 4. Remember I said 5 over x raised to the power of 4 is the same thing as 5 x raised to the power of what? Minus 4. Using the law of indices I shared in this video. So in this case, if I'm differentiating this one, what do you think is going to happen? I'm going to have 5 times times, the power of x at that point is minus 4, because 1 over x raised to the power of 4 is what? X raised to the power of minus 4. So the power of x at that point is minus 4. So you bring the power, you multiply the power with the coefficient 5, and this will be minus 4. And then you repeat what you have, which is x raised to the power of minus 4, and then you subtract 1 from it. So with this now, what do you have? You have e raised to the power of x plus 3 cos x. Now, you know that 5 times minus 4 will give you minus 20. Plus and minus is minus. And there's already an existing minus outside. So minus and minus will become what? Become plus. So this will become plus 20 x raised power minus 5. And this gives us the end result of this question. So the last question now, the last question is you're asked to evaluate ln of 3x raised power of 3 plus what? 2. So like I said, if you want to find the derivative of this, the derivative of ln x is 1 over x. So the derivative of everything here, ln 3x cubed plus 1, it will first of all give you 1 over 3x cubed plus 2. Then you now multiply by whatsoever that you have here. The derivative of ln s is equals to 1 over s only, because by the time you differentiate x is 1, and 1 times 1 over x is 1 over x. But in this case, when you differentiate the whole of this, it cannot give you x. So you first of all differentiate the whole of this. And when you differentiate the whole of this, after writing that, the derivative of ln, whatever that you have is the derivative of ln something something, first of all give you ln of that thing. So if that thing now has an expression, a long expression that can still be factorized, that is derivative, sorry, that can still be that its derivative will not give you 1, then you find the derivative and multiply it with whatever that you have. So since the derivative of a ln of this one first of all was 1 of 3x squared plus 2, then we will now check that with the derivative inside this bracket give us 1. If it gives us 1, so our answer will be what? 1 over 3x cubed plus 2. But in this case, the derivative will not give us 1. So when we find the derivative, when we differentiate 3x cubed plus 2, are we going to have? We are going to have 9x squared. You know, when you differentiate 2, it's going to give you 0. So at the end of the day, your dy dx now is equals to 9x squared over 3x cubed plus 2. I want to believe I'm making sense. So and that is the end of the examples that we have. What you are going to do for me at your end is, after watching this video, try as much as possible to solve these questions on your own by yourself without watching the video, and see what you are going to get as your result. After that, you can then practice these exercises. Please try these examples at your end. Try these exercises at your end. So now we are done with at least at the end of this section now, we have been able to achieve two things. We have been able to define what differentiation and its derivative is, and we have also been able to apply the major basic rules to both general functions, trigonometric functions, and exponential functions. So now we'll be going to product, quotient, and chain rule. Product, quotient, and chain rule.